Due to its intermittent nature, as the penetration of solar increases, it can cause adverse conditions on the electric grid that negatively impact both utilities and their customers. A real-life scenario where a utility distribution feeder experiences an over-voltage condition due to high penetration of solar on that feeder is demonstrated as follows. We are in a neighborhood on a distribution feeder with a very high penetration of solar PV. It's midday, and the neighborhoods are not using much electricity, so load on the feeder is low. Clouds had rolled in and now are rapidly rolling out. The sun suddenly shines on the solar PV. The solar output rises significantly and quickly. The distribution feeder experiences a rapid rise in voltage. Traditional utility equipment does not have time to react to such a rapid rise in voltage, so consumers are impacted. How are they impacted? Well, if the power is delivered at higher voltages, energy is wasted and the useful life of electrical equipment such as air conditioners, appliances, and lighting is shortened because they are often not running at their most efficient levels. As a result, an electric bill can be higher for a business or a home that regularly experiences higher voltage levels. In the case of severe overvoltages beyond equipment ratings, instantaneous equipment failure can occur. And over time, if such conditions persist, the local utility may feel the need to limit the amount of clean, renewable solar power that can be connected into their electric grid in order to prevent these voltage fluctuations due to high penetrations of solar. Now, with next-generation GridWave solar technology developed through the U.S. Department of Energy Solar Energy Grid Integration System (CEGIS) program, overvoltage conditions are limited by implementing something called dynamic reactive power management. Voltage on the feeder starts to rise. Smart solar systems with integrated GridWave technology dynamically respond by syncing reactive power as needed to mitigate rise in voltage above the desired level. Unfortunately, in some instances, the voltage level on the grid is not sufficiently lowered. In this case, power being generated by the smart solar systems is automatically cut back. Power curtailment is another feature that helps maintain grid stability, although cutting back on power generation would not be the first technique utilized.